In this video, we'll discuss a table of standard normal curve areas. There is a table on page 715 of the book which relates to the z-scores of normal distributions to corresponding areas under the curve. This allows us to find areas under the curve for z-scores other than 1, 2, and 3 standard deviations, as explained by the empirical rule. Because of the symmetry of the normal curve, the table can be used for values above or below the mean. For example, find the percent of all scores that lie between the mean and A, one standard deviation above the mean. Looking at the table, a z-value of 1.00, one standard deviation, corresponds to an area of 0.341 or 34.1%. B, 2.45 standard deviations below the mean. Now remember, the curve is symmetric, so it doesn't matter whether we are looking above or below the mean, we'll get the same values. Per the table, a z-value of 2.45 corresponds to 0.493 or 49.3% of all scores. Another example, the lengths of phone calls placed through a certain company are normally distributed with a mean of 6 minutes and standard deviation of 2 minutes. What is the probability of a random call lasting 10 minutes? 10 minutes is 2 standard deviations above the mean. The area between the mean and 2 standard deviations, per the table, is 0.477. The total area to the right of the mean is 0.500. We find the area to the right of z equals 2 by subtracting 0.500 minus 0.477 equals 0.023, which is 2.3%. That means that about 2.3% of phone calls will last 10 minutes or longer. One last example here. Find the total area under a normal curve between z equals negative 1.45 and z equals 2.71. In the book, you will see a little graph and it shows you what the z-scores are and what exactly the area that we're looking for is. I'm just doing it this way because to save some time. Here, one of the values is below the mean and the other is above the mean. I missed writing that, but that's what I was trying to say here. We find the corresponding areas for each z-score and subtract. So z equals negative 1.45 corresponds to an area of 0.426, and z equals 2.71 corresponds to an area of 0.497. The total area is 0.426 plus 0.497 is 0.923. B, 0.62, z equals 0.62 and z equals 1.59. I made a lot of mistakes trying to write that. Here, both values are on the same side of the mean. So we subtract the smaller value area from the larger. Z equals 0.62 corresponds to A equals 0.232, and Z equals 1.59 corresponds to A equals 0.444. So 0.444 minus 0.232 is 0.212. And that is the area between under the standard normal distribution between those two Z values.